Welcome back to Mr. Hassan's Maths channel. I'm now answering question number 2 from the June 2023 Pure Mathematics P2 International A-Level Edexcel paper. This question here is about the factor theorem. And we're told that f of x is equal to 4x cubed minus 8x squared plus 5x plus a, where a is a constant. We're told that 2x minus 3 is a factor of f of x. And we have to use the factor theorem to show that a equals negative 3. So the factor theorem is such that when you substitute whatever makes one of the factor, the x value that makes the factor 0 into the function, then what comes out is 0. Right? That's what the factor theorem states. So here we have 2x minus 3. What makes 2x minus 3 equal 0? Well, if you rearrange this equation and make x the subject, you have 2x equals 3 and x equals 3 over 2. So if 2x minus 3 is a factor, which we know it is because they told us it is, then substituting x equals 3 over 2 into this equation will give us the answer of 0. And that's how we can find a, because when we put x equals 3 over 2 in here, f of x will be 0, a will be the only thing we don't know. So basically you substitute instead of x 3 over 2, what will come out is 0, okay, because, why? What's the reason this is true? Because by the factor theorem, 2x minus 3 is a factor of f of x. Okay, so we know for sure this must be true. All right, so now we can just go ahead and do that calculation. So I can say 4 times 3 over 2 cubed minus 8 times 3 over 2 squared plus 5 times 3 over 2 plus a equals 0. Now, what is important for you in these type of questions, when they already give you the answer, like here, show that a equals negative 3, you have to take a bit more care in showing steps. So it's not good enough now just to put a equals negative 3, in such a question. All right, this will give you maybe, some of the marks here, but it's better for you when it says show that, to show some more steps. Okay, so it's just more complete for you, especially when they gave you the answer. So I would advise you to at least show the step where you do 4 times and then you multiply, you cube this number, so that's going to be 27 over 8 minus 8 times 9 over 4, because that's squared, plus 15 over 2 plus a equals 0. So the 4 and the 8 cancel, leaving you a 2 underneath. The 4 and the 8 cancel here, leaving you 2 on top. So you've got basically 27 over 2 plus 15 over 2, that's 42 over 2, which is 21. And you got minus 2 times 9, which is 18, plus a equals 0. So you can see that gives you 21 minus 18 plus a equals 0. And we know that this is 3 plus a equals 0. Therefore, we can see a equals negative 3. So we've got what we had to show once we understood that if this is a factor, then whatever makes this bracket 0 will make the whole function 0. Okay, that's basically the factor theorem. All right. So now that is, and that's true for every factor. Okay, so because when you factorize something like this, 4x cubed minus 8x squared 5 plus 5x, and now we know it's minus 3 equals, it's going to be 2x minus 3 times something, which could also factorize. Okay, maybe. All right, and if this becomes 0, the whole thing becomes 0. All right. So if this becomes 0, the whole thing becomes 0. So that's why, this is whatever makes one of those brackets 0, the x value basically makes the whole thing become 0. All right. So that's how you can find what a factor is. So that's how you can use the fact that something is a factor, all right, to answer a question like this. Now for part B, it says, hence show that the equation fx equals 0 has only one real root. Okay, so only one real solution to this equation. So we know that 4x cubed minus 8x squared plus 5x plus a equals 0 has a factor. If you factorize this, it's going to be 2x minus 3 times something. 2x minus 3 times a quadratic, which would be, we can say ax squared plus bx plus c equals 0. So this times this equals 0. All right. So if it only has one real root, that's going to be the root x equals 2/3, which is what happens when you either this equals 0 or this equals 0. So what they're basically trying to say to us is the quadratic that you get, okay, when you factorize this, okay, when you take out 2x minus 3 as a factor, this, the equation ax squared plus bx plus c equals 0 has no roots. Okay, so first of all, we've got to find out what ax squared plus bx plus c is. We've got to find out what this is. Now, there's a couple of ways we could do this. One of them is by using algebraic long division, which is what I guess most students would do. So I'll start off with that. So you have 2x minus 3 times. Then you have ax squared, then you have 2x minus 3 divided into 4x cubed minus 8x squared plus 5x plus a. Okay, one thing to be careful about when you're doing algebraic long division, make sure that all of the terms are there. So you've got x cubed, x squared, x, and a constant. If anything's missing, you have to put 0 of that thing. So for example, if the question was you had 4x cubed plus 5x plus a, there was no x squared term, you'd have to put plus 0x squared in this place to keep everything nice and neat in our division. But in this case, there's no problem. Everything is there, so we can just go ahead. So then you say, okay, how many times does 2x go into 4x cubed? Well, that's 2x squared times. I'm going to write it over here. Keep the x squareds in line. So 2x squared times 2x is, 4x. 2x squared times 2x squared times 2x is 4x cubed. And 2x squared times minus 3 is minus 6x squared. The x cubed terms and the x squared term, everything is written in the right place. You know, like right underneath that particular term. So x cubed under x cubed, x squared under x squared. Then we say, okay, 2x, then we subtract these, Then we subtract these. Okay, so when you subtract them, this will give you 0, of course. Okay, which is what should happen. If it doesn't, you've done something wrong with this. Okay, asking yourself how many times does 2x go into 4x cubed? Okay, you've done something wrong there. If these two don't subtract, this will basically end up the same as that. Then you got minus 8x squared minus 6x squared, which is minus 8x squared plus 6x squared, which is negative 2x squared. Then you say 2x goes into minus 2x squared minus x times. Okay, you bring down this next number here, and then you say minus x times 2x is minus 2x squared, and minus x times minus 3 is positive 3x. And then we again subtract. So of course this gives us 0. You have 5x minus 3x, which is 2x. Bring the next term down, which is a minus 3. We know we worked out a is minus 3, so we can just place that with minus 3. And then we have 2x goes into 2x plus 1 times, and 1 times 2x minus 3 is 2x minus 3. And there we have, there should be no remainder, because we know for sure 2x minus 3 is a factor, okay, of the expression. So definitely there will be no remainder. When you divide something by one of its factors, you get no remainder, okay. And so now we have 2x squared minus x plus 1 is what you get when you divide these. Now, so far we have f of x is equal to 2x minus 3 times 2x squared minus x plus 1. Now we know it says show that it has only one real root. Okay, so we know that when you put f of x equals 0, and you have 2x minus 3 times 2x squared minus x plus 1 equals 0, okay, one of the roots is when 2x minus 3 equals 0, so when x equals 3 over 2. This is a root. Now we've got to prove that 2x squared minus x plus 1 equals 0, this particular, factor. We got to show that this gives no real roots. Okay, so how do we prove that? We use what's called the discriminant. We use the discriminant, and the discriminant is something which helps you to tell how many solutions a quadratic equation has. Okay, and the discriminant, if your equation is y equals, or the equation is ax squared plus bx plus c equals 0. If ax squared plus bx plus c equals 0, the discriminant is b squared minus 4ac. Okay, why is that the discriminant? When you solve this equation, when you solve this using the quadratic formula, you have minus b plus or minus the square root of b squared minus 4ac all over 2a. And this part of it is called the discriminant. Why? Because that is what determines how many solutions there's going to be. If this is positive, you'll have minus b plus or minus something. So you'll have minus b plus something and minus b minus something. Okay, and then, those over 2a, you'll have two answers. So if b squared minus 4ac is positive, is greater than 0, you have two solutions. If b squared minus 4ac is negative, is less than 0, then this will be the square root of something negative which is undefined, and that will give you no real roots. If you have a negative under the square root, that will be undefined. So there will be 0 real roots. And if b squared minus 4ac is equal to 0, you'll have minus, this thing will be 0, the square root of 0 is 0, so you'll have minus b over 2a, only one answer. So that's called a repeated root, or it's called, there's basically one solution or, a repeated root. So in this case, we've got to show that this has no roots. So that means the discriminant has to be negative. So let's see if that is the case. If that is the case, we have proved that there's only one root, which was x equals 3 over 2, because this didn't give any roots. Okay, there's potentially 3 roots. This root, and then 2 from here, or maybe 1 from here if it's a repeated root. Okay, but we got to show that there's only one real root, which is the one that's already given to us. All right, x equals 3 over 2, the one when we know that 2x minus 3 is a factor. So this should have no roots if there's one real root. So now what we're going to do is we're going to say, okay, the discriminant, we're going to say a is equal to 2 and b is equal to negative 1, the coefficient of x, and c is equal to plus 1. So we're going to have b squared minus 4ac, b squared minus 4ac is equal to minus 1 squared minus 4 times 2 times 1. That gives you 1 minus 8, which is negative 7. So we can say as the discriminant is negative, therefore we can say 2x squared minus x plus 1 equals 0 has no real root. Therefore, 2x x equals 3 over 2 is the only real root of f of x. Okay, so we proved that there's only one root of f of x equals 0, because that's when x equals 3 over 2. The other part of it basically gives us no solution when we try to solve it. How do we know it's going to give us no solution? Because if you try to do it, you would end up with a negative value under the square root. Okay, so I'm just giving you some background information to what the discriminant is here. You don't need to write any of this stuff down here. I'm just giving like a little review of what the discriminant means and where it comes from. Why do we use b squared minus 4ac to determine how many roots we get? Okay, just a bit of revision. That's kind of P1 stuff, but a bit of revision of that. Okay, so that's what we have shown here in this question, which is 2 part B. A quick look at the examiner's report for this question. Okay, just to reiterate a few points to you. So it says here, this question enabled candidates to demonstrate the understanding of the factor theorem as well as being able to solve a cubic. There was a clear warning on the top of the question that all stages of working should be shown and that solutions relying on calculator technology were not acceptable. This question proved to be more challenging than anticipated, particularly given that similar questions have been asked before. Part A was well attempted by most candidates. Most knew to substitute x equals 3 over 2 into the expression for f of x, set this equal to 0 and solve to find the value for a. which is what we did. A significant number of candidates fail to show sufficient working to gain both marks. Okay, some candidates approach the question through long division rather than the required use of the factor theorem. That's part A. Okay, they said use the factor theorem, so you can't, for example, take 2x minus 3. In fact, you can't do what we did in part B, all right, with x equals minus 3 in the question and show that there's no remainder. You have to, for part A, substitute x equals 3 over 2 into the equation, because that is the factor theorem. So if you try to do it by doing long division, you will lose both marks, as I mentioned here. All right. Candidates should be encouraged to show intermediate stages of working rather than simply stating a given answer after their initial statement if they want to secure full marks. So that's what I was mentioning. You should show some working. Don't just put a equals minus 3 after showing that step here. Okay, so you don't just put this down and then write a equals minus 3. You have to show some steps, at least, especially when they gave you the answer, when it's a given answer. That's what they're trying to say, right? So it says use the factor theorem. So we can't do what we did here in part A. So I mean, this proves that this is a factor of this, and it proves that when a equals minus 3, this is a factor of this. It proves it, because you can replace a with minus 3, and you could do the long division and show there's no remainder. Therefore, 2x minus 3 is a factor, and you've proved that a is minus 3 then, because 2x minus 3 would then be a factor of this. So that would be approved, but the question did stated very clearly use the factor theorem in part A. Okay, so that's one issue. Now let's look at what it says about part B. In part B, most candidates were able to make a pleasing attempt and were able to score some of the available marks. Most carried out long division to obtain the quadratic factor, then attempted to make use of the discriminant of the quadratic factor. Many of those who got this far then failed to obtain the final mark. There were a variety of reasons referring to the quadratic factor which did not score the final mark, such as failing to state that the value of the discriminant was less than 0. So they'll say, oh, it gives a math error. Or they'll say this does not factorize. Or they'll say no solution. No, you have to mention that the discriminant is less than 0. Okay, so it's very important. Okay, so additionally, this mark was lost due to candidates failing to provide any reference to the root x equals 3 over 2, with some even stating that the only real root was a factor 2x minus 3. That is a factor, not a root. A root is what makes this 0, okay, which is 3 over 2. Candidates should therefore be reminded to provide sufficient and accurate detail when trying to deduce certain given property. So, if you don't want to lose marks for such a question as this, you have to be able to state something like this. You don't just say, oh, a math error when you try to solve this, or math error, therefore that's the only solution. You say, no, show that you found the discriminant, and you've shown that the discriminant is negative, which means that there is no root for this, which means that x equals 3 over 2 is the only real root. Okay, so it's important, you want to gain all the marks, that you don't take these kind of shortcuts. Now I'm also going to show you how we can prove, or we can find this factor, this other factor of this expression, by using what's called comparing coefficients. Okay, so I'm going to show you how to do that also, just for your complete your understanding of it. Okay, so this is like an alternative method of showing or finding the other factor of this, and then the rest of it we already did in the question. So basically, we know that 2x minus 3 was a factor. They told us that, right? That's one factor. So we know that 2x minus 3 times some quadratic, we'll call ax squared plus bx plus c, will give you, when you multiply them, it will give you your f of x, which is 4x cubed, minus 8x squared plus 5x, and minus 3. We already told that x is a is minus 3. Okay, so we know that this will give you that. So what we can do is we can do what's called comparing coefficients. Okay, so I can think about, when I expand this, okay, for example, I can think of what will be the x cubed term when I expand this. The only way to get x cubed is when you do 2x times ax squared. All right, there's no other way of getting x cubed. If I multiply the x with the x, I'll get x squared. X with the constant, I'll get x. Constant with x squared, and so on. So the only way of getting x cubed term is multiplying 2x times ax cubed. So the coefficient of x cubed would be 2 times a, okay, which is 2a. All right? I'm not talking about this a here. That's a different a I'm talking about now. I'm talking about the a in this quadratic, all right? So we know that basically you're going to get 2 times a, all right? And we can see, all right, that should equal 4x cubed, okay? So we know that 2a must equal 4. So the x cubed term has to be, the x cubed coefficient has to be 4. So the x cubed term from here will be 2 times a, which is 2a, and 2a must equal 4, which means a must be 2. Okay, if this is 2, you get 2x times 2x squared, which is 4x cubed. All right, and the other coefficient, or the other term, which is easy for us to find because it's only one way of getting it, is when you multiply the constant by the constant. So it's always the highest power and the lowest order that gives you the easiest, calculation. So if you do minus 3 times c, okay, that will be the constant. So if you look at the constant, when you expand this bracket, it's going to be minus 3 times c, which is minus 3c. And we know that the constant here is minus 3. So you say minus 3c is equal to minus 3. Therefore, c is equal to 1. Okay, so I know c must be 1. And to find b, we can consider either the x squared or the x term. And I'll show you how we can do it for both of them. But this is where you have to be a bit careful, because there's not only one way of getting x squared. You can get x squared by doing 2x times bx. That will be x squared, so that's going to be 2b. But you can also get it by doing minus 3 times ax squared, which would be minus 3a. Okay, so 2 times b minus 3a is the x squared term. So 2b minus 3a has to equal negative 8. That's the x squared term in this expression. And we already know that a is 2. So we can say 2b minus 3 times 2 equals negative 8. So 2b minus 6 equals negative 8. So 2b is minus 8 plus 6, which is going to be minus 2. So b is negative 1. Okay, so b is negative 1. So now we found what a, b, and c is. So we know that the quadratic here, that's multiplying 2x minus 3, is 2x squared plus x minus 1. Okay, and that's exactly what we found. 2x squared minus x plus 1 when we did the division. I personally think the division is way easier. I'm just showing you an alternative method. Okay, for some people, they might prefer that. Okay, and again, if we had chosen to compare the x terms, okay, if we had chosen to compare the x terms, then we would have 2x times c, which is 2c, and minus 3 times b, which is minus 3b. And we will then say 2c minus 3b is equal to the x term, which is 5. And we already know that c is equal to 1. So you'd have 2 times 1 minus 3b equals 5. So 2 minus 5 equals 3b. So minus 3 equals 3b. So b equals minus 1. So we get the same answer whether we compare the x or the x squared terms. We see we get the same answer, b equals minus 1. And then the rest of the question is the same. We show that the discriminant of 2x squared plus x minus 1 equals 0 is negative. Therefore, that will give no solution. So therefore, the 2x minus 3 equals 0, where x equals 3 over 2 is going to be the only root. Okay, so that's just a bit of a extra way of dealing with things. How to another method of finding what that quadratic is that multiplies this 2x minus 3 to give our cubic. You can do it by comparing the coefficients. But as I said, most people prefer to just do long division, and I myself think it's a bit easier anyway. So I just wanted to give you another way of doing it. So that concludes this question number 2 from this June 2023 paper, Pure Mathematics P2. Other questions from this particular paper can be found in the playlist that will appear in this region over here. Other questions from the topic of the factor theorem from P2 can be found in the playlist, which will appear over here. You can subscribe to my channel by clicking on this link, and on the top here you can see the link to a video which explains how to use my channel in an efficient manner. Thank you for watching and see you soon.